So we are going to solve this problem 2111, which is about transformer. Um, uh, in this particular case, is a transformer for home use. So you see, there are some devices that have inside them a transformer. This allows us to use this transformer in different countries, because you see, some countries have a potential difference in the houses of around 110 volts. Some other countries have larger potential difference for larger voltage, for example, 220 volts. So if you have a transformer already inside, containing your device, you can use this device in different places. If you do not, then you can use a transformer. You can connect your device to a transformer, so then you can use it in a different country. For example, that's one use. In this particular case here, what we have is a transformer that is probably inside our radio, because our radio to function, it needs just 9 volts. Okay, but the voltage that it's going to be getting from the wall is 120. So inside this radio, we have a transformer that is going to reduce the potential difference from 120 to 9 volts. Okay, so, and then there are some questions involved in this problem. But let's first remind ourselves about the equations for the transformer. So remember, the purpose of the transformer is to change the voltage. So we call it step up transformer or step down transformer according to what happens with the voltage. And the equation for the voltage is this one that we see here. So the ratio between the voltage in the secondary over the voltage in the primary is the number of loops, the number of turns in the secondary over the number of loops in the primary. And so the voltage is proportional, is directly proportional to the number of turns. So secondary on top for both sides of the equation. Okay, so if we increase the number of turns in the secondary, we have a step up because the voltage in the secondary will increase. Current goes the opposite way. The equation for the current is this one. So the ratio secondary over primary is now primary number of loops over secondary. It's just the opposite, which means if the number of turns in the secondary increases, which means we have a step up transformer because the voltage increases, what is going to happen to the current? The current is going to decrease. Okay? All right, so let's now go to the problem. Let's see what we have. We have this transformer that is going to reduce the voltage from 120 to 9. So the primary, in our case here, for the radio, the primary is 120 volts. It's going to take us to this lower voltage, which is 9 volts. That's what the radio needs to function. This secondary, they are telling us, this secondary has 30 turns. Okay, has 30 turns, and also this radio draws 400. No, so this radio draws 400 milliamps. So that also means this is the current of the radio, which is 400. Well, we can write it as 0.4 amps. Correct? Okay. So now comes the questions. Part A, calculate the number of turns in the primary. Okay, so the question here is, what is the number of turns in the primary? What do you think? Is it going to be more or less? Well, of course, think a little bit, but I'm going for the answer. Of course, it has to be more, right? The voltage, the ratio of the voltage, as we wrote here, no? the ratio of the voltage, Vs, Vp, is the ratio of the number of turns, Ns and P. So if Vp is larger than Vs, then Np has to be larger than Ns. No? So that's to say that Np has to be larger. How? Well, you go to this equation here, put all the numbers that you have. We have Vs, we have Vp, we have Ns. What we want to find? Np. You put all the numbers there, and you're going to see that the answer here is 400 turns, of course, large. Okay, the next question, question B, is the current in the primary. So you think, what do you think? The voltage we know that the voltage in the primary is larger than the voltage in the secondary. So how about the current in the primary? The current in the primary should be smaller than the current in the secondary. And again, we go now for this equation. What we want to find is this current here. You put all the numbers there, and you're going to get that the current in the primary is smaller than the current in the secondary, and it is 0.03 amps. Okay, very good. So this was question A, this was question B, and now comes the last question, question C, which is um, the power transform, the amount of energy per time that is transformed. The power transformed is IV, and you can choose any of the two. You can use IPVP or ISVS because we are not changing the energy. We are just changing the voltage and the current, but we are not changing. So this product is constant. We are changing each one of the terms, but the product is constant. So you use any of the two, for example, IS multiplied by VS, and you get here 3.6 watts. Unit for power, remember, is watts in the international system.